Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing acidity of phenols. Now I will continue from there. Phenol, you know that in benzene ring OH group is attached. With benzene OH group is attached. And carbon to which OH is attached, that is sp2 hybridized. Due to the higher electronegativity of sp2 hybridized carbon of phenol to which OH is attached, electron density decreases on oxygen. Again you listen, this is an important point. Due to the higher electronegativity of sp2 hybridized carbon of phenol to which OH is attached, electron density decreases on oxygen. This decreases the polarity of OH bond and results in an increase in ionization of phenols than that of alcohols. Now we can see the stability of alkoxide and phenoxide. Which one is more stable? Now I am going to discuss that things. That out of alkoxide and phenoxide, which one is more stabilized? Then here in alkoxide ion, the negative charge is localized on oxygen, while in phenoxide ion the charge is delocalized. The delocalization of negative charge, actually there will be resonating structures. 4 resonating structure will be there. Already I have discussed. The delocalization of negative charge makes phenoxide ion more stable and favors the ionization of phenols. Although there is a charge delocalization of phenols, its resonance structures have charge separation, due to which the phenol molecule is less stable than phenoxide. Here important point is that the delocalization of negative charge, there are 4 resonating structure. The delocalization of negative charge make phenoxide ion more stable and favors the ionization of phenol. Although there is charge delocalization for phenols, in phenol also there is a charge delocalization. Its resonance structures have charge separation, due to which the phenol molecule is less stable than phenoxide ion. 4 structures I have told you that you can understand easily. Now suppose on benzene OH was attached. Now suppose H is not there. H gone as H plus. Then on oxygen 3 electron pair will be there. In normal case, oxygen will have 2 lone pair of electron, as in phenol. OH is there, then in that O 2 lone pair of electrons are available. But when H will go as H plus, then its electron will be taken by oxygen. Then now one more pair will increase. Means 3 lone pair of electron will be available, and it will be oxygen will be negative. And now it is called now this is called phenoxide ion. Phenoxide ion, because now H ion is not there, it gone. Hydrogen plus H plus ion is not there, it gone. Okay. Then now what will happen, that this structure you consider as a structure 1. Means now O is attached, having three lone pair of electron, and it is negatively charged. Then here this oxygen and carbon bond is near the double bond of benzene ring. Near the double bond of benzene ring. Then now in second structure what will happen? Now easily you can understand that because carbon and oxygen is a single bond, then it can donate lone pair of electron, one lone pair of electron to single bond, and it will make double bond, and that oxygen will become that this one pair of electron will be given to single bond. Then now it became double bond. Then now continuously 2 double bond will be there, one between carbon and oxygen, and other just that carbon and other carbon. Then continuous 2 double bond is not possible, because that carbon will have in that situation 5 valency. That is not possible. Carbon has maximum 4 valency. Hence obviously that benzene ring double bond will shift, or you can tell that bond will break, and that electron will go to the next carbon. Correct? And again what will happen? Again this electron can make double bond with next carbon. Then again there was also alternate in benzene ring, alternate double and single bond are there, alternate single and double bond will be there in benzene ring. Then now that this lone pair of electron will make a bond with next carbon, and from that carbon to the other next there is again double bond, and when new bond will form double bond, then old double bond will break. Then now again that double bond will form, and next old double bond will break, and that next carbon will have negative charge. Like that way, four you can say structure will be formed. Then at ortho position and at para position, and again ortho position, means carbon number 6. Now negative charge rotated. This negative charge delocalized, means from the ortho to ortho, then after that para, and after that again ortho, means carbon number 2, carbon number 4 and carbon number 6, they will have negative charge. Correct? Then as soon as it will reach the charge will reach to the carbon number 6, means ortho position, opposite to the beginning. Second was ortho, and now 6 is again ortho. You know that there are 2 group ortho, 2 meta, 2 ortho, 2 meta, and 2 this position, para position. Okay, but here with respect to O, now we'll get only 1 para position. Then now when electron will reach to the sixth carbon. Then now because it is electron, then this carbon oxygen double bond, it reached to the carbon oxygen double bond. Then now due to this electron there will be repulsion. Then that double bond which C and O means double bond of C and O will break. It will go back. And this carbon number 6 which has a double bond, which have this electron pair. This carbon number 6 has an electron that will make double bond with carbon number 6 and carbon number 1. Double bond. And what was the double bond between C and O? That will become single bond. Then again original structure you will get. Original structure. Only what was the difference in doing that? Only that double bond rotated. Position of double bond just rotated, means where it was single that became double, where was the double it became single, means rotation took place. Okay. Then due to this phenoxide ion becomes stable. Okay. That's why in phenol this is not possible. In phenol that because H group is there, H group is attached there, then there is only two lone pair of electron. Then there also rotation will take place. There also already discussed, there also that one lone pair of electron will make double bond between oxygen and carbon, and again complete rotation will be there for double bond. Correct? There also will get 4 structure. But that time when oxygen will move, oxygen will electron of oxygen will make double bond between carbon and oxygen. Oxygen will have positive charge. Correct? That is the only difference. But then here in phenol 2 lone pair of electron is there, but here 3 lone pair of electron is there. Correct? That's why it is now stable. Phenoxide ion is more stable than phenol. Phenol molecule is less stable than phenoxide. Okay. And again you see in substituted phenols, next important point I am telling you, you remember phenoxide ion is more stable than phenol. Okay, this question is asked. Now further I am telling you, in substituted phenol, suppose in phenol any other group is attaching. Sometimes maybe electron withdrawing group, sometimes maybe this electron donating group, okay, or electron releasing group. Then what will happen? That is called substituted group. Then in substituted phenols, the presence of electron withdrawing groups such as a nitro group. Nitro is a positive charge. It will attract the electron. It will withdraw the electron from benzene. And now you see that now oxygen has 3 lone pair of electron, and NO2 suppose it is attached with benzene. Generally benzene will attach either at ortho position or para position, because these 2 position negative charge will be there during resonance. Then it is suitable place, ortho and para position, that position is suitable for NO2. Then now suppose NO2 group is attached. In substituted phenols, the presence of electron withdrawing groups such as nitro group enhances the acidic strength of phenol. Okay, because it will attract the electron. NO2 will attract the electron. Then now what will happen? At oxygen, electron density will be less, and it will not able to donate the electron to H. Hence H will go outside. Then it will lose the H. Then loss of hydrogen, loss of proton. That is the sign of acidic property. Correct? That's why this phenol will lose the proton, means H plus. This effect is more pronounced when such a group is present at ortho and para position. It is due to the effective delocalization of negative charge in phenol oxide ion. On the other hand, electron releasing group such as alkyl groups in general do not favor the formation of phenoxide ion. If electron releasing group is attached, such as alkyl group, maybe methyl, maybe ethyl, in general do not favor the formation of phenoxide ion, resulting in decrease in acid strength. If electron withdrawing group is attached, then because it is releasing electron, then on oxygen electron density will be more. Then when electron density is more, then hydrogen will not leave. It will be attached with oxygen only, because hydrogen is getting electron. Then when it will not leave, then it will be not called acid, or you can tell acid strength will be less. Correct? Because it is not losing the hydrogen. If it will lose the hydrogen, then it will show more acidic character, but it is not losing, because on oxygen more electrons are available for hydrogen. Hence it will not leave. That's why acidity decreases. Correct? Then electron releasing group such as alkyl group, maybe methyl or ethyl, in general do not favor the formation of phenoxide ion, resulting, and what will happen if it is not favoring formation of phenoxide ion, then what will be its effect? Then resulting in decrease in acid strength. Srisol or cresol, whatever you want, you can tell. Srisols, for example, are less acidic character than phenol, because it will release, this srisol is electron releasing group. Only phenol is there, no group is attached electron, this is a releasing group. Then if no electron, this releasing group is there, only OH is that, phenol is there, then that time, and now when srisol is attached, it will supply the electron, it will release the electron, it will donate the electron. Then that situation, hydrogen will not leave. It means acidity will decrease. Then in that case, phenol is more acidic than srisol. In comparison to phenol, srisol is a weak, you can say, weak acid. Okay. This acid strength of phenol will be more than srisol. Okay. Then srisol, for example, is less acidic than phenol. This I have discussed because many questions is asked on this concept. Now I think you will be able to answer. Now next properties I am discussing. Next property, this I have discussed about the acidity of phenols. Now next chemical properties or chemical reaction of this ethyl alcohol and phenol. Now I am going to discuss. Then that is the esterification. Esterification means formation of ester. Here you should understand only in the beginning. I am briefing you because this alcohol. Alcohol is ROH. R is alkyl group. Or if you will think phenol, then that phenyl group will be there, benzene ring. Okay, phenyl group and OH will be attached. Then OH is a main role is of OH here. Then OH means now consider these things, ethyl alcohol. Alcohol you consider ROH. R means alkyl. And now suppose it is reacting with acid or any other which has a double bond O, not double bond, COOH, carboxylic group or anhydride, then because they have oxygen, more oxygen, anhydride with one oxygen, 2 CH3CO is attached. That you know. With one oxygen, 2 CH3CO will be attached. Then there is a possibilities to break the bond, in both cases. COOH, maybe formic acid, maybe acetic acid, correct? Then there in acetic acid structure also you should know CH3COOH. Forget CH3, you can tell as a R dash. Okay, R dash means a different alkyl group. Sometimes this ROH in that R, suppose it is methyl and acetic CH3. Then that time when both are CH3, then group will be same. Means that CH3 is also, that here CH3 also you can tell acetic acid R, and there ROH also R, if both are a methyl group. If one is methyl, other is, if methyl, another is ethyl, then that time you can tell R dash, correct? R and R dash, if both groups are different. If same, then you can tell both places R will be there. And now here main things I want to tell you, actually here carboxylic group COOH, its structure will be C double bond O. One oxygen is attached with double bond with carbon, and other OH, that is O is attached with carbon with single bond, means carbon and oxygen single bond, and with oxygen H is attached single bond. Then this C double bond O, that bond will not break because it is strong. Then which bond will break? Then carbon and oxygen, bond between carbon and oxygen, single bond is there, that bond breaks, correct? Then now easily you can understand, when this bond will break, then oxygen will take electron and it will become negative, means OH will be negative and carbon will be positive. When bond COH bond will break, between, means carbon C and bond between carbon C and O, then carbon will get positive charge and O will get negative, means OH will be negative. This you remember. This is a very, very important point. And this side ROH is there. ROH is there. Then here what will happen? That OH bond will break. OH bond will break. Then what will happen? H will go as H plus, then O will be negative. O will be negative. Means RO negative will get. RO negative will get. And H will go as H plus. Then now in a simple way, that now this charge development taken place. Means in carboxylic acid also two charges there, positive and negative, and this side also ROH positive and negative is there, means hydrogen positive and oxygen negative. Then now what will happen, that these ions will go to the opposite charge. These ions will go to the opposite charge, means negative will go to positive. And what you will get, that is actually final product. Then obviously you will get two product. One product will be ester. Ester formula you know, RCOOR. RCOOR. Correct? Then sometimes both are maybe same, sometimes other will be R dash, if group is different. But RCOOR, that is the ester group. Remember, RCOOR means ester. R may be, both may be same, both may be different. If one is methyl, then other will be ethyl group. Correct? Then R and R sometimes may be same, R and R dash sometimes may be different. Then main things I have told you. Now you will understand quickly esterification. Okay. Then alcohol and phenols react with carboxylic acid. It will react, it can react with three possibilities are there. It can react with carboxylic acid. Second possibility is it can react with acid chloride. Acid chloride, RCOCl. Acid chloride means RCOCl. Remember, RCOCl. COCl is acid chloride. Correct? And third possibility is that it can react with anhydride, acid anhydride. Okay. Then already I have told about the anhydride structure. And acid chloride is simply CH3COCl, acyl chloride. What you are telling? Acyl chloride. Okay. Then this you consider as a R only. Sometimes C2H5 may be also there. Propyl group may be also there. Okay. Then it can react, alcohol or phenol can react with these three, and it will form ester. Reaction by reaction, now you will understand very easily. Now suppose you consider anyone, either phenol or alcohol. Phenol is phenol, if you are considering phenol, then AR, aromatic. AR means shortcut aromatic, capital A, small r. Okay, aromatic. And R you know that R means alkyl. Alkyl group is denoted by R, and AR is for phenol, phenyl group. For phenyl group AR, and for alkyl group R. Okay. Then any one you can consider, phenol or ethyl alcohol, phenol or alcohol, any one you can consider. Because this group is now it is not going to anything in formation of ester. This will be there, either phenol and other phenyl group or alkyl group. It will be there. But ester formation you are considering. Then what will happen? Already I have told you. Then now suppose we consider ROH, anyone. Then ROH plus RCOOH. RCOOH. Correct? R may be methyl group, R may be ethyl group. Then now RCOOH is there. Then it will form, what it will form? Already I told you, RCOOH. Then one oxygen is have double bond, and that will not break. Other COH, then CO bond will break. Correct? Then two charge developed, and here ROH, O and H will break, and then O minus H plus. So now just if you write on paper quickly, we will understand. Just you join negative and positive. Join negative and positive ions. You will get ester. Correct? And other product you will get water, because OH bound of acid and H plus of alcohol, it will form water. Then RCOO of acid, that carbon is positive, then it will join with oxygen of alcohol. Correct? Carbon will join with oxygen. This is important because oxygen is, RO is there, O is a negative charge. Then this carbon, RC double bond O, that carbon is positive, and RO, that oxygen negative, hence this carbon will join with oxygen. Then what you will get? You will get RO, again C. You will find, because a carbon will join with oxygen. Then C, and that C double bond oxygen is there. Double bond oxygen is there. Correct? Then here 2 oxygen is there. That's why it is in general way you can write R C double OR. Correct? RC double OR. Then it is very easy to understand that RC double OH was there, acid. In that one R is already there, and in alcohol also one R is there. Then total 2 R is there. 2 R is there, and 2 oxygen. After making product, you are getting 2 oxygen and 2 R. Then and 1 carbon will be there, because this carbon only joined with oxygen. Hence you can write in general way RC double OR, but exact way you will write RO. Only from this O carbon has joined. Then you can write RO, and then you write C, and with C double bond oxygen was there, and from this carbon 1 R was also attached. That is a carboxylic acid, that R. Then this is actually called ester. It is called ester, means ROCOR dash. COR dash. Then CO means double bond, and with this carbon R dash was there from the acid side, carboxylic acid side. Then now ester is formed. Same way with these things. Anhydride also same way it will react, because this anhydride formula you can keep in mind very easily. With oxygen 2 CH3CO is attached. Oxygen is there, and then 2 valence is there. Then one side CH3CO, other side also CH3CO. Then here you understand CH3CO. Then CH3 is attached with carbon with single bond, and CO, that bond is double. C and oxygen double bond is there. Then 2 plus 1, 3 valence is over. 4th valency means this carbon's 4th valence is joined with oxygen. Correct? Same way other side. CH3C double bond is there, and this oxygen is joined with carbon. Then here what will happen in this reaction, when alcohol or phenol, anyone, when it is reacting with anhydride, then here important point to understand is that now from where bond will break. Then always if carbon and oxygen is there, bond is between carbon and oxygen, then only from there bond will break. only from there bond will break. Means bond between carbon and oxygen, that bond will break, and and who will take the electron? Then only electronegative element will take the electron. Means that will become negative, that will take the electron. When bond will break, electron will be, who will take the electron? Then in comparison to carbon, oxygen is more electronegative, and that electron will be taken by oxygen, and that oxygen will become negative and carbon will become positive. Now see, here also two charge developed, means carbon became positive, and this CH3CO, correct? Then CH3CO, then this C will have a positive charge. Now this I told you, bond will break between the C and O. Then electron will go with O, that will become negative. Then now you can see oxygen is joined with both sides. O is joined with carbon only. Then now think any one, CO bond will break. Then carbon will have positive and oxygen will have negative. Then now you will get CH3C double bond O, and again one oxygen, that will have negative. Means one side you will get two oxygen. Correct? And that oxygen, one oxygen is double bond, other oxygen is single bond having one, you can say this thing, the negative charge, CSR C double O, and with this C only, O is there which has negative charge. Then now see the situation, ROH, that OH bond will break from alcohol side, then H will become positive and O will become negative. Then that H plus, now it will come with C double bond O, and again one oxygen attached, that is negatively charged. From here H plus will come. Here H will come and it will form RC-OH, means acid will be formed. Then one product is over. Now come to the main product. Then in alcohol, RO minus is there, remaining RO, one oxygen is there, one minus. That RO means O will join with carbon. Another part, carbon was having positive charge. There this RO will join, means RO will join with O of the RO will join with carbon of second part. And now we can see that RO now joined with carbon, and that carbon already it was having CH3CO, correct? Then now full structure will be CH, in the place of CH3 you can tell R only. Then RCO, and after that carbon was there which was positive. Only from that carbon now O joined. O has joined with this carbon. Then now again here you can see, now it became there in this structure 2R is there, and 2 oxygen is there, and 1 carbon is there. Then RC-OR, you can write RC-OR. Then now, but real structure will write how? RC means R and C that is a single bond. C, carbon oxygen double bond. After that, that carbon was joined with, you can say, RC double O. That was joined with carbon. And then one double bond you have written R. It is joined with C. That carbon has double bond with oxygen. And that carbon is joined with O. And that from that O, now what happened? Now it is positively charged. This carbon is positively charged. Then OR has joined. From this carbon, OR has joined. Hence correct structure will be RCO, again COR, because with this oxygen R is attached from alcohol side. Then this is again ester, that is the second product. Then here in case of anhydride, you will get two products. First you will get ester and second will get acid. Second product will be acid. Okay. Now third example you can take, that is with acetyl chloride, alkyl chloride, RCOCl. Then same example in case of phenol also. In the place of alkyl R, you can write PH or AR. AR means aromatic, means benzene phenyl group. Same thing, no difference. Okay. Then now RCOCl. Now suppose alcohol and RCOCl is there. Then again you can understand same thing will happen. Same thing will happen means alcohol is there. Then that OH bond of alcohol will break. Then O will get negative charge, RO negative, H positive. And this side RCOCl is there, acetyl chloride. Then here this bond will break, RCOCl. Then this C and Cl bond will break. Then Cl will be negative and carbon will be positive. When RCOCl bond will break, C and Cl bond, then Cl will be negative because it is electronegative. Carbon will come positive. Then this Cl negative and H plus from phenol or alcohol, that H will come and join with Cl. It will form HCl. Then now when this bond RCOCl bond broken, then that time Cl got negative charge, but that carbon got positive charge. Means RCO, that C is positive. Then that will go and will join with RO. O was having negative because H gone as H plus. Then this carbon RCOCl, that RC will go and join with oxygen. Then now again you can see two alkyl group will be there. Two alkyl will be there, one from alcohol side and one from acetyl side, RCOCl. Then two alkyl group and one carbon and two oxygen, because one from RCO and RCO, and from the acetyl side RCO was there, this side also. There was in alcohol ROH. Then one oxygen was there, and here is this alkyl, acetyl or alkyl, this is chloride, not alkyl, this acetyl chloride. Then there also one oxygen, CO is there, and that C joined with oxygen of alcohol. Then now two oxygen is there, two alkyl group is there, and one carbon is there. One carbon is there. Then now again it is called ester. It will form ester, ROH RO, and from this R only COR is joined, hence it forms ester. Other product is HCl. This is actually formation of ester is called esterification. The reaction with carboxylic acid and acid anhydride is carried out in the presence of a small amount of concentrated sulfuric acid. This reaction is reversible. The reaction is reversible, and therefore water is removed. In case of acid, water will form. Then this reaction is reversible, therefore water is removed as soon as it is formed. The reaction with acid chloride, means acetyl chloride, this is carried out in the presence of a base. Then example of base here is pyridine. Pyridine is a base. Okay. And then here this reaction with acetyl chloride reaction will take place in the presence of base, that is a pyridine. So as to, why it is a base is used? So as to neutralize HCl, because acetyl chloride will give HCl product. Then that is the acid, and acid will be neutralized by base. That's why here base is used. An example of base here, suitable base is pyridine. Correct? Then it will neutralize the acid, okay, which is formed during the reaction. Now it shifts the equilibrium to the right hand side, means only you will get ester because HCl is removed. Now another things I want to tell you, I am going to discuss now that thing. Introduction of acetyl group. Actually CH3COCl is there. If Cl is not there, then it will be called acetyl group. CH3CO. Then C double bond O is there. Double bond oxygen is there. C is attached with oxygen with double bond. Then one valence is remaining. R CO. Only 3 valence is there. 4th valence is opened. Then now introduction of, this is called actually acetyl group. CH3CO group is called acetyl group. Then this acetyl group you want to introduce in the benzene ring. The introduction of acetyl group in alcohol or in phenol, anywhere. The introduction of acetyl group in alcohols or phenols is known as acetylation. Introduction of acetyl group either in alcohol or phenol is called acetylation. Acetylation of salicylic acid. Very important product I am telling you, very useful product I am telling you. Acetylation of salicylic acid produces aspirin. You might be knowing aspirin is used for the patient who is suffering from heart attack. It is a medicine, very, very important medicine for the patient suffering from heart attack. Then now just give more attention how it is formed. It is formed from salicylic acid. Then now we will think, what is the salicylic acid? Then in a benzene ring, if 2 group is attached, one carboxylic acid and other OH group, means suppose in phenol COOH group is attached, carboxylic group. Suppose at with respect to OH, next to OH, carboxylic group is attached. Then this is called salicylic acid. Remember, with phenol, if COOH group is attached next to OH, then that is called salicylic acid. Then Now you know that it is very easy to understand the formation of or introduction of acetyl group. Here acetic anhydride you can use for introduction of acetyl group. Acetic anhydride you can use. Then now I told you mechanism. What will happen? That bond with oxygen to CH3CO group is attached. With oxygen to CH3CO group is attached, and you want to introduce this CH3CO group with where it will go. Then because it is a phenol, then just like alcohol, what I discussed here, H, O and H phenol, OH, that bond will break, then oxygen will be negative, H will be positive. Then this case again with acetic anhydride, what will happen? That RCO or CH3 C and O double bond. After that carbon is attached with oxygen, that bond will break. Then oxygen will get positive charge. This carbon will get positive charge, oxygen will get negative charge. Then means this thing CH3 C double bond O. That carbon to which this bond double bond is there, oxygen, that will get positive charge, and this when bond will break C and O, then electron will be taken by the rest oxygen. Oxygen will take the electron. That will be negative. Then now here you give the importance for this positive carbon. Then this CH3 C double bond O, that carbon positive charge, it will go to the phenoxide ion. From where H ion gone, oxygen was negative, it will go and join there. Correct? This positive carbon will go to the negative oxygen, means phenoxide. There it will. Now you can tell salicylate ion because COOH group is attached. That's why it is called salicylate ion, just like phenoxide ion. Then now this acetyl group introduced in the place of H. In the place of H now this CH3CO group attached, because carbon was having positive, oxygen is negative. Then this is actually called aspirin, or another name is acetyl salicylic acid. Acetyl salicylic acid. Okay. And other product, what will be the other product? Then acetic anhydride. Now that what is remaining? Then remaining will be again CH3CO and one oxygen. CH3CO and one oxygen, which is negative charge. This negative charge it got after breaking that carbon oxygen bond, that negative charge. And now this is the other CH3CO, and again from this CO, one minus is there, one minus is there. Then CH3 C double O, and that oxygen is last oxygen, second oxygen, that is negative charge. Then hydrogen released from the phenol, that will come here. It will form CH3 C double OH, means acid, acetic acid it will form. This is the second product. Second product. Then now I told you how you will get aspirin. Aspirin is used as medicine, very very important medicine for the heart patient. Now I am telling you other reaction in which carbon oxygen bond will break. Now we have seen in alcohol or phenol, O and H bond was breaking. O and H bond was breaking. Now other possibility is that carbon and oxygen bond will also can break. ROH is there. Then now we have seen O and H bond broken. But now second possibility is that R and OH, then R and O bond also can break. R means here, R means methyl, ethyl, whatever way. Then C and O. Cleavage of C and O bond means breaking of C and O bond. Cleavage of carbon and oxygen bond. Then on this basis, what will be the you can say product you will come to know when C and O bond will break either in alcohol or in phenol. Then now reactions are based on breaking is also called cleavage. Correct term is cleavage. CLEAVAGE, cleavage of carbon oxygen bond of alcohol or sometimes in phenol also. Then first I am telling you that but here in the beginning I want to tell you the reaction involving cleavage of CO bond take place only in alcohol. Phenol show this type of reaction only with Zn. Zn is required for phenol for breaking this bond. You remember it. Question is asked. Then now I am telling you that's reaction. First reaction with hydrogen halide, HCl. HX you can tell, HX in general, particular HCl. Then now alcohol plus HX, ROH plus HX. Then you know what will happen? That OH of R, because now carbon and oxygen bond will break. Then OH will go and from the HX, H will go. Then OH and H, it will form water. And when OH will go from the R, then R will be positive charge, means carbon will be positive charge. And from the HX, H plus gone. Then X will have negative charge. Then negative will go to the positive. That's simple way. Then you will get two product. RX, X will go to the R. X is negative charge, R is positive charge. RX means just like a chlorobenzene. Alkyl halide. It will form in general alkyl halide. Chlorobenzene, bromobenzene, like that way. Okay. Then it will form RX plus H2O. The difference in reactivity of three classes of alcohol. Alcohol is a primary, secondary, tertiary alcohol. In that sense, you understand the difference in reactivity of three classes of alcohols with HCl. Okay. Then actually it is used to distinguish them from the one another. Which one is primary, which one is secondary, which one is tertiary, that can be distinguished, okay, from one another by treatment with HCl. Then actually for this differences to distinguish, Lucas test is done. Lucas test. What is actually Lucas reagent? Then it is a concentrated HCl plus ZnCl2, zinc chloride. Remember, question is asked, Lucas test. What is the Lucas reagent? Then it is concentrated HCl plus ZnCl2. Don't forget. Then alcohols are, now listen carefully, alcohols are only alcohol, any alcohol you can take. Alcohols are soluble in Lucas reagent. Okay, it is soluble. Alcohols are soluble in Lucas reagent. What is the Lucas reagent? Then HCl and Z, mixture of HCl and ZnCl2. Then alcohol will be soluble in Lucas reagent. While their halides, now see the value of halides. While their halides are insoluble. Halides are insoluble. Okay, like ethyl chloride, methyl chloride. Then this will be insoluble in Lucas reagent. While their halides are these things immiscible. It will not mix, or insoluble you can tell. Immiscible and produce turbidity. It will produce turbidity to the solution. Now further you can say, in case of tertiary alcohol, primary, secondary, same situation. Now come to the tertiary alcohol. Then actually here one more point you have to know, that halides are immiscible and produce turbidity in solution. Then turbidity, sometimes it will form quickly, sometimes slowly. In case of tertiary alcohol, turbidity is produced immediately. As the form of halide easily. Why they are forming immediately? Because they form the halides easily. That's why turbidity is produced easily. Okay. Then now secondary you can understand. Tertiary it forms very easily, and primary will be considered soluble. Secondary will give turbidity, but it is immiscible and it will give turbidity slowly, but tertiary will give fast. Correct? Then this I told differences. One will dissolve, other will be immiscible, and it will give turbidity. This is for secondary, but slowly. But tertiary will give turbidity fast, because HCl will be formed, means this halide will form fast. Now another example is, other reaction is dehydration. Dehydration, by name it is very clear. Water will go from the molecule, H2O will go. Correct? And when H2O will go, it is just like elimination reaction, only from the same molecules. Generally in elimination reaction, water will form and it will go. Sometimes halide can form and can go, and generally it will take from, in alkane it happens, alkane. Then in alkane, suppose two bond is breaking, then in alkane single bond will be there. Then when the molecules goes out, then it will make a double bond. Okay, because that this reaction bond will break with you can say nearest carbon, with adjacent carbon, that atom will go from the adjacent carbon, and when atom will go, then one atom will, when it will go, it will create positive charge, and another carbon, when that atom will go, that will create negative. Then positive and negative, they will make a bond. Negative means it has electron, a pair of electron, it can make the bond. That's why positive and negative carbon both will make double bond. One, then alkane will become alkene. Major things I have told you. Now with example I am telling you, now you can understand. Alcohols undergo dehydration, means removal of molecule of water. Then after that, what it will form? To form alkenes. After removal of water, it will form alkenes. Alkene means double bond. On treating with protic acid. Protic acid means what? Acid which can give proton H+. That is called protic acid. Example is concentrated H2SO4 or phosphoric acid, means H3PO4. Okay, these are called protic acid. Or you can say catalyst. Catalyst also required here, such as anhydrous zinc chloride, ZnCl2, anhydrous without water. Water should not be there. Or alumina. Alumina means Al2O3. Then one reaction I am telling you. Suppose this, you take example of methyl alcohol, and not methyl alcohol, you take example of ethyl alcohol, CH3 CH2 OH, CH3 CH2 OH, means 2 carbon is there, with 1 carbon 3 hydrogen is there, and with another carbon 2 hydrogen is there and 1 OH group is attached. Then only 2 carbon is there, in 1 carbon 3 hydrogen, other carbon 2 hydrogen and 1 OH. Then this OH of first carbon and H of 1 H of the second carbon, H and OH it will form. When it will H will go, then it will go as a H plus, and when OH will go, it will go as a OH minus. Then OH minus H plus, it will form water and it will go. Then when H plus, H gone as H plus, then that carbon was having negative charge, carbanion. It formed, I can say negative charge, you understand, that carbon will be negative. And OH minus went, and that OH, as OH minus went, that carbon became positive. Then now this negative carbon and positive carbon, they will make one bond. Then now it became double bond. In the beginning it was single bond, now it became double bond. Okay. Then this reaction takes place at temperature 443 Kelvin. This reaction takes place. Now think for the secondary and tertiary alcohol. This is the C2H5OH, that is the primary alcohol. Now secondary alcohol means carbon to which oxygen is attached, that is attached with 2 carbon. Means you can take the example of propyl alcohol. Propyl alcohol, then OH is attached with the middle center carbon. Then again same way, if you are using any acid, either concentrated acid or phosphoric acid, H3PO4, it will be 85% roughly you can take. Then now same reaction will take place, because OH is attached with the central carbon, then it either first or third carbon, that will involve, their hydrogen will involve in bond formation. OH and H of either first or third carbon will go, and their double bond will be formed. Then it will form actually this propylene, it will form propylene, carbon first and second will be double bond. One double bond and other single bond, propylene plus H2O. And now think for the tertiary, then same thing will happen. Same thing will happen, that again with carbon, with the carbon with to which OH is attached, that carbon is attached with 3-methyl group. Then again what will happen, that these things OH of central, OH is attached with the middle carbon. Then that OH and second carbon H, that will go as H2O, and that carbon only 2 CH2 will remain, and that carbon, middle central carbon and first carbon, that will make a double bond. Then here again what will happen, now it is becoming, because total 4 carbons are there, one was in the center and 3 methyl group was attached, then it will form what? It will form butene. Okay, plus H2O. Then now if you have to compare that this thing, which reaction will go fast out of primary, secondary and tertiary, which reaction this dehydration process will take place, with which alcohol it will be fast. Correct? That I am telling you. Then the relative EG of dehydration of alcohol follows that tertiary is greater than secondary, secondary is greater than primary. Means tertiary will form, tertiary will lose H2O faster than secondary, and secondary will lose faster than primary. Why? What is the reason? Then tertiary 3-methyl group is attached. Then methyl group is attached, that will release the hydrogen. Correct? Then 3-methyl group is there attached with tertiary, and this due to this 3-methyl group, it can lose the OH very easily. Okay, it is becoming easy. All three are methyl group is, they will give they will release electron. Then tertiary is will release means dehydration will take place in tertiary faster than secondary, and secondary alcohol will lose the water greater than primary. Okay, tertiary will lose will dehydrate faster than secondary, secondary will dehydrate faster than primary. Okay, then their mechanism, already I have discussed. It is very actually in this reaction takes place in presence of acid. Then acid means H plus will be there. Then actually OH and role of acid, I am telling you, acid is a protic acid, H plus it will give. Then this H plus and OH of alcohol, it will form water. It will form water. Then OH actually lone pair of electron, 2 electron, lone pair of electron is with oxygen. Then one lone pair of electron will be given to H plus. H plus. That's why that bond will break. That C and OH, CO bond will break, because that OH, that is giving one lone pair of electron to acid H plus. Then now it will form H2O, and then that after losing that, oxygen is releasing, donating one pair of electron. Then that oxygen till this up to now it is attached with the carbon or OH, what we are telling. Then now when it will give one lone pair of electron to H, then it will form one bond. Then now see, oxygen is making 3 bond, which is not possible. That's why C and O bond will break. C and O bond will break, and it will go as a H2O, and carbon will have positive charge. Carbon will have positive charge. Correct? Then now carbon has positive charge. Then suppose it was the ethanol. Then first carbon 3-methyl group is there. 3 hydrogen is there with first carbon. Then one carbon can say hydrogen of the first carbon, that will go out, leaving its electron. Then second carbon already CH2 was there. Now from here also first carbon, which was CH3, so ethyl alcohol CH3 CH2 OH, then that CO bond broken. O is having positive charge. This positive charge is due to this positive charge. Now that first carbon hydrogen is going by leaving its electron. Then carbon will have negative charge. Hydrogen will go as a H plus. Then this plus carbon and minus carbon, they will make double bond. Okay, means you will get ethylene. And hydrogen is released. That hydrogen, it is going as a H plus. It means what you taken in this section, what H plus was used, now it is going back. Now I am stopping only here. Thank you.